called, or the shortest distance between 2 points, or we are saying that when we cover this when between 2 points, when we provide a distance direction to any length, it's called displacement. Now come to the speed. Speed means the rate of change of distance. Rate of change of distance. The rate of change of distance mean distance divided by time. Rate of change mean distance divided by time.
Time.
The distance divided by time, distance traveled divided by taken time, it's called speed. And representation of speed is V. We represent the speed by V, as well as the velocity is also represented by V. But in the velocity only, we have change in displacement, mean change in displacement or displacement. You remember
Yeah.
displacement upon time, it's called velocity. Distance upon time, it's called speed. So we define the velocity. Distance in the velocity is the distance traveled in a specific direction, or it also may be defined as the rate of change of displacement. It's called velocity. Velocity is a vector quantity because velocity have a direction, and speed is a scalar quantity because speed doesn't have any direction.
Yeah.
Got it?
Okay. Yeah.
We discuss the 4 types of speed: uniform speed, variable speed, instantaneous speed, and average speed. Average speed means total distance upon total time. Uniform speed means when a distance cover in equal interval of time. For example, if I have, I have a body and it's traveled starting from a point from A toward B, toward C, and then toward D. From A to B, the distance is 2 kilometers and cover in 1 hour. After that, from B to C, it's also 2 kilometers and cover in 1 hour. From C to D, 4 kilometers and cover in 2 hours. When we divide 2 upon 1, it's equals to 2. 2 upon 1 equals to 2. 2 upon 1 equals to 2. Mean when a body cover equal distance in equal interval of time, it's called uniform speed or constant speed. If we are finding the uniform velocity, then a body cover equal displacement in equal interval of time, it's called uniform or constant velocity. In velocity, we use only the displacement word, and that for the speed, we use the distance word here. Now, if I'm talking about the average means total distance upon total time for the speed. If I want to calculate the average speed, then average speed denoted by, wait a while, average speed denoted by this symbol. It is called average speed. V in the sign. V in the sign mean the average speed. Average speed equals to a total distance upon total time. Total distance upon total time. It's called average speed. If I am talking about the average displacement, then average velocity, then average velocity is equals to total displacement upon total time. Okay, for example, a body travel from point A toward B, and then toward C, and then toward D, and come back to A. If they are saying that what is the displacement the body covered, then the displacement will be 0. Why 0?
Because it's back to its original position.
It's back to the original position. That's why we cover 0 distance. Then what is the average velocity?
0 divided by the time taken.
Yeah, then it's also average velocity will be 0.
Yeah. Yeah.
Okay. So
Okay.
the velocity is related to the displacement and speed is related to distance. Got it?
Yeah.
Okay. Now come back to the instantaneous velocity or instantaneous speed. In previous lecture, we already discussed the instantaneous speed mean the speed at any instant of time. Mean when we are traveling in a, for example, we are walking and we calculate randomly, we calculate our speed, or we are traveling in a car and directly we look at the speedometer and calculate the speed of a car. It's called instantaneous speed. Or if we are talking about the instantaneous velocity, velocity, then any instant of time when we cover at any instant of time when we calculate our velocity, it's called instantaneous velocity. Or same, the instantaneous speed in a particular direction, it's called instantaneous velocity. Formula is same. Change distance divided by time. Change in distance divided by time is equals to speed, or change in displacement upon time, it's called velocity. Got it?
Yeah. Got it.
Okay. Now come to the graph. Just wait. If we are talking about the graph, but before the graph, I want to know about the acceleration. Have you any idea about the acceleration? What is an acceleration?
Yeah. It is the speed increasing per second.
Speed increasing per
Second.
Okay. But I want to share another thing, because speed is not related to the acceleration. Speed have no relation with the acceleration. Okay. Sometimes the speed is constant, but there is an acceleration. It's mean acceleration is related only to the velocity. If I want to define the acceleration, then acceleration is equals to change in velocity, not in speed. Okay. Change in velocity upon time, not change in speed upon time. Acceleration is equal to velocity upon time, not change in speed upon time.
Okay.
Okay. Acceleration have two words, acceleration and retardation or deacceleration. When the velocity is increasing, that time we says acceleration. If the velocity is decreased, that time we says deacceleration or retardations. Same if
Okay.
we are defining the acceleration, then acceleration also have four types of acceleration. The uniform acceleration, if the change in velocity equal in interval of time, it's called uniform acceleration. Non-uniform acceleration mean when the change in velocity is not equal interval of time, it's called non-uniform acceleration. Instantaneous, at any instant of time we calculate the acceleration. And average mean total change in velocity upon time, it's called average. Got it?
Yeah. Got it.
And formulas and the unit for the speed, velocity and acceleration. Now come to the main part of the kinematics. In main part of the kinematic, we basically we discuss about the graphs. There are two type of graph. First is distance time graph and the other one is speed time graph or velocity time graph. One is distance time, the other one is velocity time.
You wrote this is speed time graph.
Sorry?
You wrote speed time graph. You said distance time graph. Yeah, but why is it S in
S
the y-axis?
S represent the distance, not the speed. Speed by V. Speed is representing by V, not with S. S is displacement, and we represent this velocity or speed. When you are in physics, then you represent V for the speed. Mean the representation of speed is equals to V, not S.
Okay.
That's why I'm saying here speed distance time graph, and in this one I says the velocity time graph. Got it?
Okay. Yeah.
Okay. Now, in the when we are discussing about the graph, then that time basically we discuss about the gradients. What is gradient, by the way?
Rise over run.
Rise over run. Rise over run, or the second thing is x upon y upon x is the gradient.
Yeah.
Yep. So here we discuss about the graphs, how we have the graph situations, and how we recognize the graph. What is the line? For example, the displacement graph, I have in the displacement time graph, I have a situation. I have this straight line here. Mean in ST graph, I have a straight line here. What is the gradient of this line?
And this distance divided by time.
Distance upon by time. Then distance upon time is equals to
Speed.
speed. It's mean the gradient of this line shows the speed. It's mean in the distance time graph, we should show the gradient of the distance time graph represent the speed or velocity of the body. This line,
Okay.
the gradient is constant. This line shows the gradient is constant, because if I calculate the gradient on that point or in this point or at that point, all the gradient are equal. If we have a straight line, for example, I have a line parallel to the x-axis like this, or parallel to the y-axis like this, that time the gradient will be 0. If a line in a graph is parallel to the x-axis or the y-axis, that time the gradient will be 0. But if the line in the graph is only straight like this line, not parallel to the x or y-axis, that time this line shows the gradient is constant.
It's a uniform acceleration.
No, it's uniform speed, because it distance time graph. In the distance time graph, the gradient shows the speed.
Speed on.
So
Okay.
this graph shows the gradient is constant. If the gradient is constant, it's mean the body move with a uniform velocity. Got it?
Okay.
Now,
Yeah.
next one. If I have this type of graph, like a curve, then this curve shows, in the previous lecture, I already told you, the curve which is made on your left hand, it shows the decreasing gradient. And when the curve made on your right hand, then that curve shows the gradient is increasing. This curve is on the left hand.
This left hand is for decreasing and right hand is increasing. Yeah.
Yeah.
Then this is right hand. So
Right,
increasing.
it's increasing. So if I calculate the gradient here, here, or here, then it's increasing gradient. Gradient increase with the time. So this shows the speed or velocity increase with. Got it?
Got it. Yeah.
Come to the next parts, the second opinion. The second one, the curve shows on the left hand side, and the left hand side shows the gradient is decreasing. If I calculate the gradient at P or at Q or at R, that time all the three lines, what they show, the gradient at point R is shows the negative gradient. Why? Because it's going down. It's going down.
Yeah.
then it's mean the gradient is negative. If the gradient is negative, mean the velocity or the speed is decreasing. The velocity or speed is decreasing.
Decreasing.
Okay, the direction of velocity change. The direction of the velocity change. If the velocity is there, then the direction of velocity will be changed. If the speed is there, it means the speed is decreasing. At the Q point, the gradient will be 0. Why? Because it's parallel to the x-axis. The Q
Yeah, it's straight line.
axis, it means the gradient will be 0. It means the velocity is 0. If I want to calculate at P, then what's happened at P? What's
Rise over run.
No. At P, the gradient is positive, na? Like this.
Yeah.
If the gradient is positive, it means the direction of the velocity is in positive and the velocity is increasing.
Yeah.
Okay. Now, here's a question. A car has traveled past a lamp post of the road, and the distance of the car from the lamp post is measured every second. The distance and the time reading are recorded at a graph is plotted using the data. The following page are the result of 4 possible journey. The stepper the line, the greater the speed. For example, at 0 distance, at 0 second, the distance will be 25. At 1 second, the distance will be 25. At 2 seconds, the distance will be 25. At 3, distance will be 25. 4, 25. 5, 25. If I draw the points at 0 is 25. First point is this A. And the second one is there. The third one is this. The fourth one, the fifth one, and the sixth one. I draw the straight line. I join all the lines, all the point like that. Then it will be like this.
Yeah.
Okay, it's parallel to the x-axis.
Yes.
It's mean the gradient parallel to the x-axis. Then what it mean? Gradient will be
0.
if the gradient will be 0, this graph is distance time graph. Then the distance time graph shows the speed of the body. It
Is
means
0.
the gradient is 0, then the speed will be 0. If the speed will be 0, it's mean body at a rest. This graph,
Stationary.
yes, this graph mean the body at rest or stationary.
Okay.
Okay, now come to the next graph. For example, I have another situation. For example, a car moving, just wait. A car moving with a uniform speed of 10 meter per second. At 0 second, the distance will be 0. At 1 second, the distance is at 10. At 2 second, distance 20. It's covered 20 meter. At 3, 30, 4, 40, and 5, 50. Plot the graph. For example, for 0.00, for 110, for 220, and 330, 450, and 550. Then the line will be drawn like this. It is a straight line here. Draw a straight line here. Join all the points. Then it will be not parallel to the x-axis or not parallel to the y-axis. It's mean when the line are straight and not parallel, it's mean the gradient is constant. The gradient will be constant.
Constant.
If it is constant, then the speed time distance time graph represent the speed. It means speed of the body is constant. Speed of the body is constant. Now come to the next one. A car moving with a non-uniform speed. For example, for first second, it covered 10 meter distance. For second, it's covered 25 meter. And at third second, it's covered 45. For the fourth, it's covered 70. For the fifth, it's covered 100. If I plot the graph, then it should be a curve graph here. The line will be a curve. And this line, this curve is representing on the right hand side. It's mean the gradient is increasing. The gradient is increasing. If the gradient is increasing, the distance time graph shows the speed of the body. It's mean body move with increasing speed. Clear it? Are you there?
Yeah, and then my mic is muted.
Okay. Okay, now come to the next one. अब हमारे पास जो है वो क्या आ रहा है, वो कार इज डीएक्सेलरेटिंग. कार इज डीएक्सेलरेटिंग. डीएक्सेलरेटिंग मीन द कार स्पीड is decreasing. Deaccelerate mean the car speed is decreasing. It's mean the gradient is also decreasing. I draw the graph on the screen as a distance time graph, but the gradient of this line is decreasing. It's mean speed is decreasing. If the speed is decreasing, it's mean the gradient is also decreased.
Decreasing.
So the
Yes.
speed of the body move in a decreasing value. Okay, the body move in a decreasing. Just wait, I will be there.
Okay.
Done? Have any
Yeah.
question? These type of graphs in DT graph, mean distance time graph, or ST graph, mean displacement time graph. Any question about the distance or displacement time graph?
One question: if in distance time graph, if the gradient is increasing, for example, then the speed is increasing, yeah. But then what happens to the distance? The distance is also decreasing or increasing, or what?
No. Here you check the in this graph, the distance from 0 till 30 is increasing. From 30 to 40, 55 is also increasing. From 55 to 75 also increasing. From 75 to 90 is also increasing. The distance is increasing, but the rate of distance, mean from here, from 0 to 30, it's 30. From 30 to 55, it's 25. From 55 to 75, it's 20. From 75 to 90, it's 15. From 90 to 100, it's 10. The rate of increasing is decreased. That's why the gradient is decreased. The distance is
Okay.
distance or displacement is increasing, but the rate of change is decreased. So the gradient is decreased. That's why the speed is decreasing.
Okay.
ठीक हो गया? अच्छा. Okay, move to the next. Now come to the velocity time graph or speed time graph. In the speed time graph, the same line, for example, this line. In the ST graph, ये line किसको show कर रही थी?
Distance. No, yeah, speed.
Speed को show कर रही थी, but represent क्या कर रही थी? What is representing that graph? The same graph
Speed.
wait a while. I mention here ST. For example, this one is a ST graph. Then this straight line, which is parallel to the x-axis, parallel to the x-axis,
X-axis.
the gradient will be 0.
0.
Gradient will be 0. It's mean in the ST graph, this line shows the body at rest because speed is 0. In the ST,
Yeah.
I am saying talking about the ST graph. But now, if the same line coming in VT graph, अब अगर same line VT graph में हो, then it's again shows the gradient is 0. I am totally agree. But the gradient of VT graph is
0 also?
No. Yani mean the VT graph show gradient shows acceleration. Na?
Yeah.
Then it means the acceleration will be 0.
Yeah. Yeah.
Acceleration will be 0. What about the speed or the
Speed
velocity?
will be constant.
Constant. It's mean the same line. It's the same line. For example, this same line represent in ST graph. This same line represent in ST graph. It's mean the body at rest. But the same line where it's come in VT graph, it's mean the body move in a uniform speed. देखो सेम ही लाइन है, दो चीजों को रिप्रेजेंट कर रही है. फर्स्ट में क्या रिप्रेजेंट कर रही है? ऑब्जेक्ट एट रेस्ट. एंड सेकेंडली क्या रिप्रेजेंट कर रही है? ऑब्जेक्ट मूव इन अ कांस्टेंट स्पीड बिकॉज ऑफ ड्यू टू द gradient. The gradient shows the 0. This line shows the gradient will be 0. But in the ST graph, gradient shows the velocity or speed. In the VT graph, gradient shows the acceleration. If the acceleration is 0, it means the speed is constant. It's mean in the VT graph, if this line comes, it's mean the gradient will be 0, acceleration is 0, but velocity is constant. In the ST graph, same again, the velocity acceleration, the gradient will be 0, mean speed is 0, mean object at rest.
But the distance will be constant.
Yes, distance will be constant. उसका मतलब ये है ना बेटा, for example, a body is still here at A. The body is still here at A. Then the distance will be for time interval. For example, for 1 second, the distance will be 10. For 10 second, also 10. Per second also 10. Mean the distance is 10. The body at the same point. So that's why the body doesn't move. That's mean the body is at stationary. But when it is in VT graph, it's mean the body move in a uniform with the uniform velocity. Got it?
Yeah, got it.
Now come to the next. It's mean the acceleration, the velocity is uniform in this type of graph. In the next graph, this line shows the gradient is constant. It's mean the velocity, the acceleration is uniform here. This line mean in the VT graph, the object is moving in a uniform velocity. This line shows the uniform acceleration, mean the velocity is increasing. The velocity is increasing. But the acceleration is uniform. About the curve, if we have a curve here, then this curve shows, for example, point A. At point A, it is increasing. At point B and point C. At point B, it's, for example, at point C. First of talking about the point A. Then at point A, the gradient is positive. Gradient is positive. It's mean the velocity is increasing. At point A, the velocity is increasing. At point B, the gradient is 0 because it is parallel to the x-axis. It's mean the gradient is 0. That time the acceleration is 0. That time the acceleration is 0. At C, the gradient is negative. It's mean downward. It's negative. It's mean the velocity or speed is decreasing and the acceleration is retardation that time.
Okay. Yeah.
Okay, area under the graph of the VT graph only. I'm not talking about the ST graph. Area under the graph in VT graph is equals to distance or displacement. Mean these all the lines. For example, if they want to know about the total distance in this, then I covered like this, and these all the area, it's equals to the distance. If they are saying that in the second graph, how much the total area is, then I draw the line here, and this all the area under the graph from this point, from the starting till the end, it is called the distance or displacement of this body. Okay, then area under the graph in VT graph is equals to displacement or distance. If it is speed time graph, then the area under the graph is distance. And if it is velocity time graph, then the area under the graph is displacement.
Displacement.
What?
How can we find the distance in the curve graph? Curve.
In your examination, there's no distance under the graph calculated by the curve in your examination. But उसके लिए ये है कि फिर आप उसको calculate करोगे by the tangent. We draw a tangent here. We draw a tangent here. For example, I want to calculate at this point. For example, here. Okay. For example, here I mentioned the point D, and I want to know about calculate the distance here. Then that time I draw the tangent here. What is tangent?
A triangle
No,
or
again,
the straight line?
a straight line which cut a curve at a single point. For example, this
Okay.
B line, I draw a B line here, it is a tangent. I draw a C line here, it is a tangent. I draw a D line here, it is a tangent. Then when we calculate the area under the graph by the curve, that time we draw the tangents. But in O-level, tangents are not included under area. We are calculating the
Okay.
area under the graph by the straight lines only. For example, इसमें आपके पास different type के questions होंगे. For example, let's see. For example, I have a curve here, a question here, and वो मुझसे कह रहे हैं कि calculate the distance. For example, VT graph है मेरे पास. अब मुझे इसमें क्या दिया गया है? लाइंस दी गई हैं. एक दे दी गई यहां से ऐसे गया हुआ, ठीक है. उसके बाद दे सेइंग दैट द सेकंड वन ट्रेवल लाइक दिस एंड अगेन एन ऑब इट्स कवर लाइक दिस. नाउ वो क्या करेंगे? वो आपसे मांगेंगे द डिस्टेंस कवर इन द ऑब्जेक्ट फॉर द सर्टेन टाइम, मे बी फॉर द सर्टेन टाइम, for the whole journey, depend upon the question. For example, I mention here some values. For example, this value is 30. This one is 3 seconds. This one is 8 seconds. And this one is 10. अगर वो आपसे कहें how much the distance cover in first 3 seconds, so I draw a line here, then it will be a triangle. Triangle बनी यहाँ पे.
Yeah.
We have a triangle, then calculate the area of this triangle. Then the area of triangle have a formula half into base into height. Then the base is from 0 till 3. Height is from here to here, 30, and multiply by half. Then 2 cut with the 30, 2 15s are 30, 15 3s are 45. Then the area of this triangle is 45. It's mean a distance covered by the body in first 3 seconds is 45 only.
45.
If they are saying that calculate the distance cover in first 8 seconds, then draw the line here at 8 seconds. Okay. Now, अब अगर आप गौर से देखो, अगर मैं इसको रिमूव करता हूं, इस वाली लाइन को, सॉरी, इस वाली लाइन को मैं रिमूव कर देता हूं, तो जरा गौर से देखो, वी बिकम अ ट्राइपीजियम.
Yeah, trapezium.
Calculate the area of the trapezium. We have a formula for the area of the trapezium.
क्रॉसिंग करना है
A plus B times height divided by 2.
A plus B into height. A plus B mean the of the parallel
Is
sum of the
easy,
parallel
and
side
the only
this
obstacle
side
is
from
hard.
here, from 0 till 8, and from this point from 3 till 8, this will be 5 and this will be 8. So A plus B is 8 plus 5 and half into height. Height is 30. 2 ones are and 2 15s are 30. Then 8 plus 5 is 13 plus 30. How much is 13 plus 30, 13 multiplied by 30?
113 multiplied by 30.
Yeah. 13 multiplied by 30.
3,390.
3000, no, but it's a very huge amount. 30
So
multiplied
113 times
by 13, beta. Because 5 plus 8 is 13, na? 390 is the answer.
but
8,
you wrote the 130.
no, sorry, it's not writing here. Only 13. 13
Oh, okay.
it's 390. It's mean the total
390. 390.
area will be 390. So the distance cover in first 8 seconds is 390. Got it?
Yeah, got it.
This all type of graph are completed. Your definition is completed. Your kinematics will be ended today.
Okay.
Okay. Inshallah, in next class, we start about the past paper and the question of this chapter. And inshallah, we completed in the next class whole our past paper and question about the kinematics.